Hello students, my name is Surya Prakash Pandey and today we are going to solve some important question based on linear differential equation. So how we find integrating factor and how we solve linear differential equation we had already done in the previous class. Today we will learn how to solve question that comes from linear differential equation of order 1 in different competitive exams. So here we have a question y prime minus tan x into y equals to 2x sec x and value of y at x equal to 0 is 0. If you think you can solve this question, please pause this video here and try to solve this question and see which of these options are true, and then you can check your answer later. Okay, so let's start. So first of all, we find integrating factor I of x, which is equals to e raised to the power integral of minus tan x dx, which becomes e raised to the power ln cos x, which becomes simply cos x. Now, solution of given differential equation is y times of integrating factor equals to integral of q into integrating factor. So this is our q and this is integrating factor. So their product is simply 2x because sec x and cos x are reciprocal of each other. So their product will cancel each other. Dx plus constant of integration. You know, integral of 2x is simply x square plus constant of integration. Now, since it is given that value of y is 0 at x equals to 0, so put x equal to 0, y equals to 0, we end up getting 0 equals to 0 plus c. It means constant of integration is 0. So finally, solution of this equation can be written as x square over cos x. Otherwise, we can rewrite this as y equal to x square sec x. Now, value of y at x equal to pi by 4 is y pi by 4 is simply pi by 4 square into sec pi by 4, which is equal to pi square over 16 into 2 into root 2. So this becomes pi square over 8 root 2. So first option is correct. Next, let us find the value of y at pi by 3. So this is pi over 3 square into sec pi by 3, which becomes pi square over 9 into 2, which becomes 2 pi square over 9. So B option is incorrect. Again, in order to see whether C or D option is correct or both of them is correct, we need to find y prime. So y is x square sec x. Let us differentiate this by using product rule. So it becomes x square, derivative of sec x is simply sec x tan x plus 2x into sec x. Here 2x is simply derivative of x square. Now we can say x into sec x is common. So what left is x tan x plus 2. Now let us plug pi by 4 at x equal to in place of x. So we get pi by 4 into sec pi by 4, which is root 2. Tan pi by 4 is 1. Multiply this. We are clearly able to see that this cannot be equal to pi over 18. So we can conclude that this option is not correct. Okay, so finally, let us plug x equals to pi by 3. So this is pi by 3. Sec pi by 3 is simply 2 pi by 3 into tan pi by 3 is root 3 plus 2. Multiply, we get 2 pi square divided by 9 into root 3. Otherwise, this becomes 3 root 3 plus 4 pi over 3. So we conclude that fourth option is also correct. So basically in this question, first option means option A and option D are correct, and these two means option B and option C are incorrect. Okay, let us see one more question. So here we have a simple linear differential equation of order 1, and it is given that the value of y is 0 at value of y is 2 at x equals to 0, and we have to check which of these statement is true. So in order to find which of these statement is true, first of all, we have to find solution of this differential equation. And for that, let us write it in the standard form. So let us divide everything by 1 plus e raised to the power x. So it becomes y prime plus e raised to the power x upon 1 plus e raised to the power x times of y equals to 1 over 1 plus e raised to the power x. So again, we can see this is a standard linear differential equation. So let us find integrating factor. Here integrating factor is equal to e raised to the power p dx, which becomes e raised to the power x upon 1 plus e raised to the power x dx, which becomes e raised to the power ln 1 plus e raised to the power x, which becomes 1 plus e raised to the power x. So our integrating factor is simply 1 plus e raised to the power x. Now let us see the solution of this differential equation. So y times of integrating factor is equal to q. Here q is basically a reciprocal of integrating factor. So q times of integrating factor is simply 1 plus constant of integration. So y times of 1 plus e raised to the power x is simply x plus constant of integration. Now put, since it is given that y equals to 2 at x equal to 0, so put x equal to 0 and y equals to 2. So we get 2, 1 plus e raised to the power 0 is 0 plus c. So it gives us constant of integration is 4. So our solution function is simply y into 1 plus e raised to the power x is x plus 4. Now let us see the first option. It says y of minus 4 is 0. So once we put x equal to minus 4, this side is 0. So 0 divided by 1 plus e raised to the power minus 4 is again 0. So y of minus 4 is 0 is correct. because minus 4 plus 4 gives 0. So our right hand side is 0. So y of minus 4 is 0. Otherwise, you can rewrite this as, okay, hopefully everyone had copied this. So let me remove this to create some space. Okay, so y can be written as x plus 4 over 1 plus e raised to the power x. So we can see that y at x equal to minus 4 is 0 because numerator of this expression is 0. So first option is correct. And y of minus 2 is basically 2 over 1 plus e raised to the power minus 2, which is not 0. So y of minus 2 is not 0. As a result, we can conclude that second option is not correct. Next, we have to see why x has critical point in minus 1 to 0 or not. So in order to find critical point, we need to find derivative of y. And for that, let us remove all this. So let me remove all this. Okay, so finally, y is x plus 4 over 1 plus e raised to the power x, and we already conclude that our first option is true and second one is not true. So in order to say why x has critical point or not in minus 1 to 0, let us find derivative of this function. So derivative is simply 1 plus e raised to the power x whole square, 1 plus e raised to the power x into 1 minus first function into derivative of second function. Let us simplify this. So we get 1 minus x into e raised to the power x minus 3 e raised to the power x upon 1 plus x 1 plus e raised to the power x whole square. Please see denominator is always non-zero. Let us take this numerator at gx. Let gx is 1 minus x e raised to the power x minus 3 e raised to the power x. So whenever gx is less than 0, actually y prime is less than 0. Whenever gx is more than 0, y prime is also more than 0. So simply find the value of gx at x equal to negative 1. So we get 1 minus 1 e inverse minus 3 times of e inverse, and this term becomes 1 plus e inverse minus 3 inverse, and this term becomes 1 minus 2 over e. Since e is more than 2, so this quantity is more than 0. Again, let us find the value of z at x equal to 0. So put x equal to 0 in this expression, we get 1 minus 0 times of e raised to the power 0 minus 3 times of e raised to the power 0, which becomes 1 minus 0 minus 3, which becomes minus 2 less than 0. Since value of gx is less than 0 at x equal to 0 and more than 0 at x equal to negative 1, so by intermediate theorem, we can say gx must have zeros between negative 1 to positive 0. Therefore, our original function y must have a critical point lying between -1 to 0. So option C is correct. And since we are saying yx has a critical point in the interval -1 to 0, it means yx has no critical point in this interval -1 to 0 is not correct. So in this question, basically, first and last options are correct. First and second last options are correct, and second and fourth options are not correct. Let us see one more example. Here, again, we have a simple differential equation, and it is given that value of y is 1 at x equal to 1. So let us write this differential equation in standard form. Let us divide everything by x. So we can rewrite this equation as dy over dx plus 2 over x into y equals to x. Now p is obviously 2 raised to the power x. So what is our integrating factor? Our integrating factor is e raised to the power 2 over x dx, which becomes e raised to the power ln x square, which is simply x square. Now find solution of this differential equation. So integrating factor into y equals to integral of integrating factor into q, where q is simply x dx. So it becomes x cube, and integral of x cube is simply x raised to the power 4 over 4 plus constant of integration, and this term is nothing but y times of x square. Now put x equals to 1 and y equals to 1. So this term becomes 1 and this term becomes 1 over 4 plus 3. So from here we get constant of integration is 3 over 4. Now plug this value in, say, equation 1. We get y times of x square is equal to x square x raised to the power 4 over 4 plus 3 over 4. Now divide everything by x square. We get y equals to x square by 4 plus 3 by 4 x square. This is our solution of given differential equation. Let us see the last. So which option is correct? So option number 3 is correct and other options are not correct. Let us see one more question based on simple linear differential equation. Here question is dy over dx equals to this much, and x lies in the open interval minus pi by 2 to pi by 2, and it is also given that value of y is 0 at x equal to 0. We have to find y of minus pi by 4. Okay. So in order to solve this equation, let us rewrite this equation as a linear differential equation. So dy over dx equals to tan x into sec square x minus sec square x times of y. This can be rewritten as dy over dx plus sec square x times of y equal to tan x into sec square x. So let us find integrating factor, which is nothing but e raised to the power integral of sec square x dx, which becomes e raised to the power tan x. Now let us write solution of given differential equation. So y times of integrating factor is equal to integrating factor into q. Here q is tan x into sec square x plus constant of integration. In order to solve this integral, simply assume tan x equals to t. So it becomes and sec square x dx. If we assume tan x equal to t, then sec square dx is simply dt. So this term is dt. Use product rule to integrate this. So once we integrate, we get t times of e raised to the power t minus e raised to the power t plus t equals to y times of e raised to the power tan x. Now, y into e raised to the power tan x equal to, in place of t, put tan x, so it becomes tan x into e raised to the power tan x minus e raised to the power tan x plus t. Now put x equals to 0 and y equals to 0, we get. So put x equals to 0, y equals to 0. So left hand side is 0 and this tan 0 is 0. So this term is 0 minus e raised to the power tan 0 is 0 plus c. So basically c is 1. So solution of given differential equation is y into e raised to the power tan x. Let us write e raised to the power tan x is common. So tan x minus 1 plus c, and c is simply 1. Okay, now we have to find the value of y of minus pi by 4. So put x equals to minus pi by 4. So we know tan minus pi by 4 is minus 1. So it becomes e inverse. Here it becomes e inverse. Tan of minus pi by 4 is minus 1. So it becomes minus 2 plus 1. So divide everything, multiply both sides by e actually. So we get y equals to simply minus 2 plus e. So basically y equals to negative 2 plus e, otherwise e minus 2. So third options is correct and other options are not correct. Okay, so hopefully all of you find these examples helpful. Try to solve other question also, and if any one of you find anything difficult in these examples, please let me know in the comment section. Thank you.